Qualitative analysis question from May-June 2007, variant 3.2. In this question, they have said you are provided with three solutions, FB 6, 7, and 8, each containing one cation and one anion. One or more solutions contain a halide ion, which could be chloride, bromide, or iodide. One or more solutions contain a sulfate or sulfite ion. Identification of anions we have to do in this first part, in this FB6, 7, and 8. And here they have said, by the reference to the qualitative analysis notes, you are to select the use of one reagent to the precipitate of any halide ion that is present, a second reagent to confirm the identity of those halide ions present. Because the solutions are colored, you will need to remove traces of solution from the precipitates. Record the test performed, the practical procedures used, and the observations made for each of the solutions. Present this information as clearly as possible in a suitable format in a space below. So now they have said you have to identify the anion which is halide in these FB 6, 7, and 8 three solutions. And they have given you the space here where you have to draw a particular table that is relevant to identify the anion that is halide ion in these three solutions. Here are the three solutions, FB6, 7, and 8. And here are the bench reagents, sulfuric acid, ammonia, sodium hydroxide, and silver nitrate. Now, once we are selecting the solutions, we will see in the table of anions where the chloride ions, bromide ions, and halide ions are tested. In these three ions, we need to add silver nitrate first, which results in the formation of precipitates. And then we look for the solubility of those precipitates in ammonia. So the two reagents we will select here in this case are aqueous silver nitrate followed by aqueous ammonia. So we will write here in the table for these three. So let's draw the table first. Here I have made the table in which I have made three columns for FB6, 7, and 8. And then I have written here, okay, first of all, we will add a few drops of silver nitrate to a 1 centimeter depth of each of these three solutions, which will result in the formation of precipitates. And then we will add in the same test tube, dotted line means in the same test tube, we will add further 2 centimeter depth approximately aqueous ammonia solution, which will confirm the solubility of those precipitates. In this way, we will identify the halide ion present in these three solutions. So let's perform these three tests. Now, let's take 1 centimeter depth of FB6 first. So this is FB6. We will take 1 centimeter depth of FB6. And now we will add a few drops of silver nitrate. So here is silver nitrate and is a dropping pipette we will use, and we will look for the color of the precipitates. So here if we see, the precipitates are white. If we closely look, white precipitates are formed from the top. Now stir this. Now look for the solubility of these precipitates in aqueous ammonia. So this is our aqueous ammonia solution, and we will add aqueous ammonia to see the solubility of these white precipitates. Once I add aqueous ammonia, the white precipitates are dissolved and a brown precipitates instead are formed. So we can see clearly the white precipitates are dissolved. Now, white precipitates are dissolved, but why these brown precipitates are formed? Because the aqueous ammonia is also used to test the cation, which is iron 3+ in this case. So red-brown precipitates here show the presence of cation iron 3+. So we will record this observation. Now we will record this observation in FB6 column. So now I have recorded this observation. Let's move on to perform the other two tests. Now we will take 1 centimeter depth of FB7 and now we will add few drops of aqueous silver nitrate and we will see the color of the precipitates. Now let's see closely. If we look closely, the precipitates are forming and from the top the precipitates are a bit yellow in color. From here, if you look, from here they are yellow in color. If we keep on adding a bit more, you can see the yellow color is getting faster. So the yellow precipitates are formed. Now we will look for the solubility of these yellow precipitates in aqueous ammonia. So upon adding aqueous ammonia, the precipitates are not dissolving. If even we shake the tube, the precipitates are not dissolving. So the precipitates are insoluble. So let's record this observation here. So here we have recorded the observation, yellow precipitates and yellow precipitates are insoluble. Let's perform the test for FB8 now. Now let's take FB8 1 centimeter approximately. And we will add again aqueous silver nitrate. So if we add aqueous silver nitrate, we can see there are no precipitates forming. So halide ions are not present. So there is no need to add further ammonia to see the solubility of precipitates because precipitates are not formed. Let's record this observation here. So we have recorded these three observations here. Now let's see which halide ions are present. So from the table we can see white precipitates which were soluble in aqueous ammonia are of chloride ion. Therefore, white precipitates of silver chloride which are soluble in aqueous ammonia. So chloride ions are present in FB6. Now for FB7, yellow precipitates were formed which were insoluble, and here we can see yellow precipitates with silver nitrate which were insoluble in aqueous ammonia are of halide iodide ions. Therefore, we will write here chloride ions are present, iodide ions are present, and there is no halide ions present. Now the next part says use your observations to identify the halide ions present and state which ions is present in which solution which we have identified here already. So we will write here and with the reasons which are here, that this is the reason we have said these are halide ions present in these chemicals. So we will write all this information here. So we have recorded all the observations here. Let's move on to the next part in the question where they say select reagents and carry out tests to show which of the solution contains a sulfate ion or sulfite ion and establish which of these ions are present. Record your tests and observation below. So first of all, we will make a table in which we will see that if we are looking for sulfate or sulfite, we add barium 2 plus means barium chloride or barium nitrate solution for both of these, sulfate and sulfite. But if we add further dilute acid, the precipitates are soluble if sulfite is present, and precipitates remain insoluble in acid if sulfate is present. So the two chemicals we are adding here are barium nitrate or barium chloride followed by dilute acid. Now here we cannot add sulfuric acid because we are testing sulfate. Therefore, we will just write here hydrochloric acid or nitric acid. So here we have made a table in which we will take 1 centimeter depth of each of these three solutions, and we will add few drops of barium chloride, followed by the HCl 1 centimeter depth to each of the solutions to look for the solubility of those white precipitates. So let's perform these tests. Now we will take 1 centimeter depth of FB6 and we will add barium chloride solution, few drops first, and we will look for the precipitates. So if we add, we are not getting any precipitates. So sulfate or sulfite are not present in the solution. Let's perform the same test with FB7. We will take 1 centimeter depth of FB7 and we will add barium chloride 1 centimeter depth. We will add few drops. Once we have added, there is no precipitates again. Now we will do the same thing with the FB8 now. In 1 centimeter depth of FB8, we will add few drops of barium chloride. Now we can see the precipitates are forming, and those precipitates are white in color. Now if we want to confirm the identity of this sulfate or sulfite, we will further add nitric acid. If we add nitric acid, the precipitates are not dissolving. It means it's sulfate. So the only sulfate ion present are in FB8, and rest of the two contains halide ions, which we have just tested before. So let's record this observation here. So we have recorded this observation here. Now let's move on to the next part, which says, state which of the ions, sulfate or sulfite, is present in which of the solutions FB6, 7 or 8, and explain how you reached to this conclusion from the tests above. So we will write here this test and observation. So we have recorded here that only FB8 contains sulfate, because once we have added barium chloride solution, white precipitates were formed in FB8, which remained insoluble in aqueous nitric acid. Now let's move on to the next part, which says identification of cations. Using sodium hydroxide and aqueous ammonia, it is possible to identify two of the cations present and draw some conclusions about the nature of the remaining cations. Carry out tests with these reagents, recording details of what you did and observed in a suitable format in the space below. So now we will perform the test for cations, and two of the cations we can find in these FB6, 7 and 8. So let's perform these tests. First, draw the table in this space. So we have made the table here for sodium hydroxide and aqueous ammonia for all these three chemicals. So let's perform these tests one by one. Now we will take the test tube and we will add FB6, 1 centimeter depth of FB6. Now we will add few drops of sodium hydroxide. Now look at the color of the precipitates observed. So if we add few drops, red-brown precipitates are forming. And if I add the sodium hydroxide in excess, these red-brown precipitates remain insoluble. It means iron 3+ is present. Now let us confirm the presence of ammonium, which can be tested by warming this mixture and test with a moist red litmus paper. So here is the red litmus paper. Let us moist this red litmus paper first. Now put this litmus paper over this tube and bend from the edges. Now warm this test tube and look at the color change. If the exposed part of litmus paper changes its color to blue, it means ammonium ion is present. Here we can see that bubbles are evolving, but litmus paper is not changing the color. It means ammonium is not present. So FB6 contains iron 3+. Now let's take 1 centimeter depth of FB7 and add a few drops of sodium hydroxide followed by excess. So we add sodium hydroxide, few drops first. We can see that green precipitates are forming. And if we add in excess, those green precipitates are soluble. So we can see a clear green solution is formed. Now we will warm this test tube and we will test for the presence of ammonium ion. So for that we will take a litmus paper. We will moist this litmus paper and then we will warm this test tube and see if the exposed part of litmus paper is changing its color to blue or not. So upon warming, we can see when the gases start evolving. Now you can see the gas is evolving, but the exposed part of litmus paper is not changing its color. It means it doesn't contain any ammonium ion. Now we will take FB8 solution to a 1 centimeter depth and we will add few drops of sodium hydroxide. Now we can see the blue color is formed. Precipitates of blue color are observed, and when we add in excess, the precipitates are insoluble. Now let us warm this tube and look for the presence of ammonium ion. Again, moist the red litmus paper and put this litmus paper on the top and warm the tube. So upon warming the tube, the gas is evolved, but there is no change on the color of litmus paper. Therefore, ammonium is not even present here. So we will record all these observations. Now, let's test these chemicals using ammonia. So first of all, we will take 1 centimeter depth of FB6 and we will add a few drops of aqueous ammonia. After that, we will add excess. So first, upon adding few drops, is a red-brown precipitates forming. And if I add in excess, those red-brown precipitates are insoluble. So we will record this observation. Now we will take FB7 1 centimeter depth, and again the same thing, we will add few drops of aqueous ammonia followed by excess. So this is few drops of aqueous ammonia. Now we can see it's a gray-green precipitates forming. If we add an excess, those precipitates are not dissolving. So the precipitates are insoluble. Now we will take FB8 1 centimeter depth and then we will add again aqueous ammonia, few drops first followed by excess. So blue precipitates start forming, and if I add excess, those blue precipitates are insoluble. But we can see that it's changing its color and now it's green also. So there are two different colors observed. Blue solution was formed, blue precipitates, but now it has turned into green color. So it doesn't confirm the presence of copper 2 plus, but yes, cation test with sodium hydroxide showed that Fb8 contain copper 2 plus, but it's not still sure. So the two cations which were confirmed are iron 3 plus in Fb6 and chromium 3 plus in Fb7. And not sure about the cation present in Fb8, but tentatively it's copper 2 plus. So we have recorded all these observations here. Now let's move on to the next part where they say explain how your observations in C identify the two cations present and which of solution contains those cations. Now if we look at Fb6, it has given us brown precipitate which were insoluble in excess in both the reagents NaOH and aqueous ammonia. So those brown precipitates were actually formed of this Fe3 plus which were insoluble in both the reagents ammonia and sodium hydroxide. So we will record this observation that it contains Fe3 plus. So we have said here Fb6 contains Fe3 plus, and the explanation for that is the red brown precipitates insoluble in excess in both the NaOH and aqueous ammonia. Now let's see the Fb7 where green precipitates were formed which were soluble to give in dark green solution with sodium hydroxide, and gray green precipitates which were insoluble in aqueous ammonia. And here it says it's chromium 3 plus because gray green precipitates which were soluble to give dark green solution with aqueous sodium hydroxide, and those gray green precipitates were insoluble in aqueous ammonia. So it is chromium 3 plus. So we'll record this observation also. So we have recorded that Fb7 contains chromium 3 plus because of these results. Now the next part they say what conclusion of general nature about the third cation you draw from your observations in C. In this case Fb8 has shown a change in color, that blue precipitates which were formed turned into green precipitates, which doesn't confirm the cation, but at least it says that it could be a transition metal changing its color. So we have recorded here that transition metal cation which forms various colored precipitates. So here we comes to an end of a 16 marks question of qualitative analysis.